In this presentation, we're going to look at how to compute the geometric mean. Now, the geometric mean is different from the arithmetic mean, which is the mean we are quite accustomed to. So, consider the data set x, which comprises of n elements. Now, the fact, like the arithmetic mean, the fact that there are n elements is important. So, we're going to make a note of that. So, we have the first element, second element, so on, all the way up to the nth element. Now, the geometric mean of the data set x is given as follows. This is how you would denote the geometric mean. It is the nth root, I'll just draw your attention to that there, the nth root, so that could be the square root, the cube root, the fourth root, of all of the elements of the data set x multiplied. So we actually multiply each of them together. So that's actually quite a bit of a tricky calculation, and a lot of people might not be familiar with how to compute the nth root. So I'm going to show you a slightly different version. So here we have it there. Consider the data set x comprised of the following elements. Well, what we could do there is, again, multiply all the elements out and then put that to the power of 1 over n. That's the equivalent of the nth root, but it's a little bit easier for people to calculate, particularly if they are not used to calculators. Right, so let's look at an example here. So compute the geometric mean of the data set x. Now, importantly, there are 5 elements here. So n equals 5, and 1 over n is 0.2. So the geometric mean, g of x, equals 1.09 times 1.11 times 0.98 by 1.05 by 1.01, all to the power of 0.2. And we would calculate that as, I'm going to compute it to 4 decimal places. That is, just bear with me a second, I have it written down here, 1.2574 to the power of 0.2. If you're unfamiliar with how to calculate powers, look for this little symbol in your calculator, the chevron symbol. And okay, so the answer therefore is, once we compute that out, we would get an answer of 1.0468. Now again, I'm just working to 4 decimal places. You probably will get a longer number than that. I just decided to work to 4 decimal places. Anyway, that is the geometric mean of the data set x.